Today we're going to work with the Algebra 1 EOC review number 4. You can see our standard highlighted here. This is going to come from your functions section, which I believe is section 3. So sometimes there are constraints to when an equation works for a real-world situation. When this happens, we have to be able to determine what the appropriate domain is for the function. The equation C of S equals 10S is given for the cost of a total number of shirts. Can we calculate the cost of a negative number of shirts? No. You can't calculate the cost of a negative number of shirts because you can't have a negative number of shirts. Can we calculate the cost of 0 shirts? Yes, absolutely. If I buy 0 shirts, it's going to cost me $0. Can we calculate the cost of a positive number of shirts? Of course, yes. Therefore, we can say that the equation represents this situation only when S, which would be our domain here, is greater than or equal to 0. Sometimes a solution to a problem does not make sense and can be eliminated. The height of a baseball after being hit by a batter is given by h of t is equal to negative 16t squared plus 60t plus 4, where h of t is the height and t is the time after hitting the ball. You are asked to find the time it takes the ball to hit the ground. After substituting 0 for the height and solving using the quadratic formula, you determine that the time is approximately 0.7, negative 0.7, and 3.82 seconds. Do both of these answers make sense? Well, this answer, negative 0.07, does not make sense because you cannot have negative time. What is the final solution to the problem? Well, if you can't have negative time, that means that the only final solution we could have is 3.82 seconds. Because it's the only solution that makes sense. Because it has to be a positive number to be time. All right. Number 7, Stephen kicked a ball inside the house. The equation that represents the height, h, in feet of the ball after being kicked an elapsed amount of time, t seconds, is h of t equals 30t minus 16t squared. The graph of this equation is shown below. Stephen's house has 12-foot ceilings. They've indicated the height of those ceilings with the function here in pink. When is the equation h of t equals 30t minus 16t squared an accurate model of the ball's path? Well, the accurate model of the ball's path is going to be from the ground to here. But what's going to happen when it hits that ceiling? Last time I checked, you can't go through the ceiling with a ball and it's going to come back down in that path. What happens when you hit that ceiling with the ball? It's going to drop right back down. So the only accurate model of the ball's path is going to be from this point, which is when my time is 0, to this point when my time is 0.58. So the correct answer here would be D. Because after 0.58 seconds, that ball's path is going to change. And when that ball's path changes, this formula here, this function, is no longer talking about the path of the ball. Okay, using the equation and graph of problem 7, what would be the constraints? And constraints is just talking about your possible x values or your domain what would your constraints be for t if the ceilings were 15 feet high? Well, if you had 15 feet high ceilings, they would be going above the path of the ball. And I know this because the maximum height that the ball reached was 14.06. So we have to choose from the numbers provided here what our constraints would be. Well, if we had a 15-foot ceiling, that means that the ball could follow the path that it had the formula for originally. So our constraints for our t, our time in seconds, right? Because that's what we're talking about, is our time is going to be from 0.0 when the ball was launched, and it's going to stop at this point, which I now kind of can't see. Which is 1.88 seconds. So t is going to be, has to be greater than or equal to 0.0 seconds, or less than or equal to 1.88 seconds. So we used those 4 signs. Question number 9. The area of a rectangle is given by a of x equals x squared plus 5x, with x being the height. Okay, I always like to draw out my rectangle. So the area is equal to x squared plus 5x. X is the height, and x plus 5 being the base. If the area is 14, so that means that x plus 5 multiplied by x is equal to 14. What is the only viable solution for the height? Why are there not 2 solutions? Okay, so I have x multiplied by x plus 5, and I know that's equal to 14. So now I need to solve this. So I have my 2 factors here. And I can multiply them out, and I would get x squared plus 5x. And that's equal to 14. And then I need to subtract 14 from both sides. And I get x squared plus 5x minus 14 is equal to 0. Now that my function is in standard form, I can solve for my x. And when I solve for my x, I would find that where'd my window go? And I would solve for that by having my factors of x plus 7 multiplied by x minus 2 is equal to 0. So x plus 7 is equal to 0. So x equals negative 7. And then I have x minus 2 is equal to 0. And once I add 2 to both sides, I have x is equal to 2. So I have two possible solutions here. X is equal to negative 7 and x is equal to 2. However, because I'm talking about height, right? It says height here. This first option of x equals negative 7 is not a viable option because I cannot have a negative height. So the only solution that I have that would make sense is x is equal to 2. So if x is equal to 2, then I know that my height is 2 and my base is going to be 7. And that makes sense because 7 times 2 is equal to 14. All right, guys, that's it for today's homework. I hope you've gotten it all done. Watch the videos and turn it in. Have a good night.